Taipei, 2203, local time. The lights just went out. Stay with me, because this was not a storm. It was a targeted kill switch. What it means for the world's most advanced technology, and what it reveals about a new form of warfare, is the story that requires telling. The target was not a military base. The target was not a government building. The target was the industrial heart of the modern world. Inside, the world's most critical manufacturing plants, TSMC's Fab 12 and 18. For them, it was already too late. This event triggered a catastrophic wafer crash. The result, an instant, unrecoverable loss of over 450,000 silicon wafers. To understand how this happened, you have to understand the paradox of Taiwan's power grid. It's a first-world technology economy built on fragile, centralized energy infrastructure. The architecture was designed for peacetime efficiency, not for war. Large, centralized thermal power plants create single points of failure. The primary threat was always assumed to be a kinetic strike, a missile. But in the 2000s, the grid was digitized. Supervisory control and data acquisition systems, SCADA, were integrated for efficiency. This efficiency created a new, invisible attack surface. The digital control plane was assumed to be a secure sanctuary. That assumption has now catastrophically failed. Let's talk about the weapon. The weapon was not a missile. It was a zero-day exploit targeting the grid's control software. This indicates deep, persistent access to Taipower's operational technology network, likely gained months or years earlier. The malware was activated at 2203. Its first move was to lie. It falsified sensor readings to the control room, masking the true state of the grid. While the operators saw stability, the malware was manipulating physical circuit breakers. This severed the connection between the northern power plants and the Hsinchu Science Park. The grid was decapitated by an invisible hand. Let's talk about grid frequency. A modern grid is a perfectly balanced machine, operating at a constant 60 Hz. The physical decoupling of generation from load caused an immediate frequency crash. The attack instantly removed 4.2 gigawatts of generation capacity, enough to power over 3 million homes. This caused the frequency to drop below 59.5 Hz. This is a death sentence for a power grid. Automated systems at the Taitan and Kuotan power plants trip generators offline to prevent their own destruction. This is the beginning of the cascade. Each generator that disconnects transfers more load onto the remaining few, causing them to fail even faster. The result is a widespread, uncontrolled blackout across the entire northern grid. But for the semiconductor fabs, the blackout was not the worst part. The worst part was the seconds of, quote, dirty power just before the failure. Let's talk about the wafer crash. TSMC's most advanced fabs consume over 5% of Taiwan's total power. Inside are extreme ultraviolet lithography machines, EUVs. These are the most complex machines ever built by humanity, costing over $150 million each. They operate with tolerances so fine that a passing truck can disrupt the process. The grid collapse and dirty power surge was not a tremor, it was an earthquake. Tens of thousands of wafers, each holding hundreds of chips, were mid-process. The power fluctuation rendered every single one of them instantly worthless. This is a write-off of over 450,000 wafers. That represents the next 3 months of the world's entire supply of advanced 3-nanometer chips. The immediate financial loss is over $2 billion. But the real cost is the damage to the EUV machines. Recalibrating them will take 4 to 6 weeks, halting all advanced chip production. The global supply of the most important product on Earth is now zero. Let's talk about the supply chain. This is not a shortage, this is a severance. Tier 1 of the cascade is immediate: Apple, Nvidia, and AMD. Their flagship products depend entirely on TSMC's 3-nanometer chips. Within weeks, their production lines in China and Vietnam will grind to a halt. Tier 2 is the automotive industry. Already fragile from previous shortages, they now face a catastrophic shutdown. A modern car contains over 1,000 microcontrollers. Most come from Taiwan. Tier 3 is the most critical, the defense industrial base. The production of the F-35, the Javelin missile, and advanced radar systems relies on specialized chips from Taiwan. The U.S. defense base now faces a critical component shortage, impacting its ability to produce its own weapons. Let's talk about the military consequences. While military bases have backup generators, they rely on finite fuel reserves. The real impact is on C4ISR, the ability to see, hear, and command. Degraded civilian power cripples the vast supporting infrastructure that modern militaries depend on. The final cascade is diplomatic. The attack creates an attribution crisis, as the lack of kinetic action provides plausible deniability. How do you retaliate against a power outage? From this morning forward, the rules are different. The attack proved that a new form of blockade is possible, a cyber blockade. It can achieve the economic isolation of a country without firing a single shot. Here is what this event means. It means the collapse of the sanctuary assumption. The belief that economic and military warfare were separate domains is now obsolete. It means the world's most valuable supply chain was built on a load-bearing assumption that has been proven false. The grid was the thermal bridge between the digital and physical worlds. The attack didn't just break the grid. It broke the firewall in the global strategic imagination. The entire structure is now unstable. The global chip shortage is now permanent. The lights are out in Taipei, and the world is running on zero.